Today, I will introduce my research on a task called human group detection. Group detection is the task of automatically finding groups of people in videos and images. For example, just like this. People enclosed in bounding boxes of the same colour are identified as being in the same group. In our research, we focus specifically on videos. However, existing methods for group detection have two significant problems. The first problem is that existing methods often fail to understand the global context of a scene. They tend to focus only on local appearance features, like the bounding boxes of individual people. But global context is essential for understanding groups. For example, look at this picture. If we only look at the bounding boxes of these two men, we can't be sure if they are a group. Are they just standing near each other, or are they interacting? However, if we see the whole picture, we can see they are both looking at this vending machine. The vending machine provides the global context. It tells us they share a common focus, and therefore they are a group. This is information we would miss by only looking at the people. Second, current methods struggle to capture the change of groups within a video. They often assume that groups are static and do not change over time. But in reality, people join groups, leave them, or form new ones. For example, look at this picture. Although their state is a conversation in T1, we can consider that the group dissolves in T2 because the woman begins to walk away. To address this, we introduce dynamic group detection. Our goal is to accurately track how groups form, change and dissolve within a video. My research presents a new method to solve these two problems. Our main contribution consists of two parts. First, to capture the global scene context, we utilise a vision language model, specifically CLIP, which we have augmented for the task of group detection. This allows our model to understand the broader scene and the relationships between people and objects. In our method, to capture both global scene context and target's groupness, we used red circle. Specifically, there are targets in the picture. We circle each target and crop the broader area to include global scene context and input clip image encoder. The reason why we used clip was that we thought that it could extract the high context, like groups, as it was trained by using both images and text. Drawing red circle in a picture directly might sound a bit unusual. However, paper published in ICCV 2023 said that clip may understand red circle and where to focus. So I used this way. Second, to solve the challenge of dynamic group detection, we propose a new approach. We use a novel graph-based clustering algorithm that performs global optimization across all frames of a video. This allows our method to maintain consistency over time and accurately detect how groups change. We tested our method on public datasets. Our proposed method outperforms current state-of-the-art group detection methods. These experiments indicate that using clip and our visual prompt 2 red circle is effective. In summary, our research makes two key contributions: leveraging local and global context through a vision language model, and introducing a method for dynamic group detection. That is all for my presentation. Thank you for your attention.